Hello, welcome back to our Chapter 7 video lecture series. And we left off looking at the general setup for a hypothesis test for association, Chapter 7.2. And I want to go over one example of how to do a test for association hypothesis test. Then we're going to use a study that was done, I think it was done in 2012. And the study was done with 2,625 respondents. And there are multiple questions, but the question we're going to focus on is, do you believe there is only one true love for each person? Some that agree, disagree, and don't know. And then we also collected, the study also collected information on their education level. So HS here is those that have a high school diploma. The some column, noted down below, is people that have some college education, a couple classes, or maybe a couple years in, but not completed. And the college column here are those that have graduated with a bachelor's or higher in college. And a little interestingly, most people have an opinion. Only 78 out of 2,600 don't know about this. Most people have an opinion, yes or no. Definitely stronger on the disagree side than agree that there's one true love. But we want to look specifically at whether there's a big difference in kind of the proportions. We're looking at the proportions of, high school, some college education, and college degree or more. Does that have an effect? Is there an association between the college level, excuse me, and belief in one true love? Okay, so I copied this information over to a Word document. I want to go through how to conduct a hypothesis test. So here I've written, we're looking at test for association, for chapter 7.2 right here. Is there an association between education level and belief in one true love? And let's conduct a hypothesis test with a significance level of 0.05. All right, copy the information. And just note down here, the categorical variables are education level, and there's 3 subcategories. There could be many more, of course, but we're just going to look at these 3. And then belief in one true love, yes, no, and then I don't know. So kind of 3 subcategories. So I'm going to write down here R, that's my number of row columns, or row options is 3. C is my number of column categories, that's also 3. And N, my sample size, is the 2625. Cool. Okay. For the null hypothesis, we're always going to assume there is no association between the 2 variables. So on homework and on the exam, I want you to be clear about what you mean by there's no association. So for this example, there's no association between education level and whether or not someone believes there is one true love for each person. So make it clear, always no association as the null hypothesis. And the alternative hypothesis is there is some association between education level and belief in one true love. So we can't talk about causality, whether or not, if you're educated, the more education, the less likely you're going to believe, or vice versa. We just say that there's some association. Okay, trying to figure out how that association works is, I would argue, a lot more complicated and interesting. We're just going to focus on whether there's evidence for or against an association. All right, okay. So what I'm going to do, I'm going to use GeoGebra. I like the GeoGebra software better than StatKey for test for association to calculate my test statistic, which is chi-squared, and it's the sum of all, let me scroll down here, the difference between the observed and expected values squared divided by the expected value of each category. So here, notice we have 9 different options. We have 9 observed categories here, or cells. So it'd be a little tedious to calculate all the expected values. As I said in the last video, I'm going to go over in class how to calculate expected values. It's not very difficult, but it is a little bit tedious. So for the exam or homework or quizzes or anything, I want you to be able to calculate expected values with technology. So I'm going to use GeoGebra. I'm going to open up Google GeoGebra, click on the probability. Once that opens up, make sure to click on the Statistics tab up at the top right. And in this drop-down menu, you have all your options here. Goodness of fit, we did in the last video for 7.1. For 7.2, it's called chi-squared test. I wish this said association or independence, but it says chi-squared test. So maybe write down, make a note. To use GeoGebra, you have to do a chi-squared test when you're doing a test for association. All right, and here, notice we've got rows and columns here. You could change these around, 4 columns, or 4 rows, 3 rows, or so on. I want to add our information here. Enter this information. So I'm going to shrink this down a bit so it's a little bit easier to copy over. Let's see, again, we don't necessarily need let's see if this will work. All right, I'll copy this down. We have the agree, disagree, don't know. And then here we've got high school, some college, and college, degree, plus. All right, in GeoGebra, you don't have to fill these out, but it just kind of helps to be organized. All right, and I'm going to enter this information basically as I see. So this agree in high school, fill in this table. And it would help as I'm going over this video if you want to pause and open up GeoGebra and enter this information. So kind of have the muscle finger memory on how to use GeoGebra for test for association. So I'm going to fill in the information. The agree in one true love from high school is 363, then 176, and then 196, 557, 466, 789, 20, 26, 32. So notice, zoom over. I don't add the totals. You don't need to add the totals into GeoGebra. You just need to add in the values, the actual counts in each category. And I will possibly could ask you, if you click here to get the expected counts. Underneath, you've got the expected counts for each. So like I said, in the next class, I want to go over how you can calculate these by hand or with the formula. And it kind of connects nicely with when we study probability. So we'll review some independent events with probability. And then you can also click on the chi-squared contribution. So notice right here, the expected counts on top. You're looking to see how different these are. If they're off by a lot, like for high school and agree, that should be 263, but the observed counts was 363. So the chi-squared contribution was 37.84. For those that agree and want true love that have some college, 176 in the survey said yes to that. And assuming there's no association between the groups, between the two categories, it should have been 187. These are not very different, so that chi-squared contribution is less than 1. Looking at those that have some college and that disagree, 466, disagree that there's one true love for each person, that have some college, and it should have been about 461. These are very close to each other, especially when we divide by the expected counts, so we have a small count. So the biggest differences seem to be with those that agree in high school, got 37, and then even with a college degree, those that agree on true love, the 27. The rest of these are pretty small. And the chi-squared value is the sum of all of that. So the chi-squared contribution, if you add up all the chi-squared contribution numbers, that leads to the 94.24259. So this right here is my chi-squared value. So that is 94, I forgot what it is, 0.259. 0.259. So I've got my test statistic, and then for p-value, GeoGebra also gives that value. P-value right here is approximately 0. Actually, I'm going to go back here and write, it's not exactly 0, it's approximately 0. And the degrees of freedom formula is R minus 1 times C minus 1. So for this example, that'd be 3 minus 1 times 3 minus 1. 2 times 2 is 4. So that's right here, the degrees of freedom says 4. And I just want to show we could get this value in stat key as well. If you go to stat key, click on chi-squared. We have 4 degrees of freedom. Click OK. Always right tail for chi-squared tests, both goodness of fit and test for association. In the bottom left, you want to enter that 94.259 into the cutoff value. And see how far that is from 0. So our p-value is going to be 0. All right, we reject the null hypothesis. This study provides, I would say, very strong evidence that there is some association between education level and whether or not someone believes in one true love. And again, so this conclusion, I think, is kind of weak. It's a weak conclusion. We assume there's no association between the two variables, that whatever some random person's education level is, whether that would affect whether they believe in one true love or not. So we can't say whether having more college education decreases or increases how much someone believes in one true love. We could dig deeper. If this were, second semester stats, we would dig deeper into this type of question and maybe do some confidence intervals or difference of proportions. But for just this one test, this one hypothesis test, all we could say is that there is some association between education level and whether or not someone believes in one true love. All right, that concludes our video lecture series on Chapter 7. We will go over some more of this, and like I said, I want to explain what GeoGebra is doing. Like, how does GeoGebra get this chi-squared, or sorry, not that. I want to explain how GeoGebra gets these expected counts. It'll be a nice review of probability for the final anyways. Okay, that is it.